Let's go through conditional statements. So conditional statements is what we traditionally call two-way decision, right? So what does that mean? Two-way decision means if this path, right? So let's say if you had to make a decision right now, if this path is not true, right? And then you go here, not true, right? What if this path is true, right? If the decision is true, then you go to this one, right? True. So it's almost like a truth-false table, right? When you are at a junction of making a decision, you have basically two choices. One is going for true and the other one's not. So that's basically the basis of if and else, right? That forms the foundations of conditional statement. And of course, sometimes you can simplify it. You can also nest, right? A whole bunch of if and else and think of this decision tree that goes from top to bottom, right? So at every single junction, there's a decision you have to make. Bayesian reasoning network, and there's some tree decision-making system, machine learning and data analytics, and they make use of these. But imagine when you have a whole bunch of the if and else and dangling else problem, things like that, how can you simplify it? So we're going to go through these specific scenarios, and then we'll introduce at the very last conditional expressions in this video. So this is your logical truth table, basically a logical flow that we were talking about that forms the decision tree. So let's say if you have your execution, flow of execution, and involves this if statement, right? If, right, expression, which evaluates for either true or false, happens, then, right, it depends on the outcome of that expression. You can either go here, right, or you can go here, right? So is it true or false? And depends on what this are. There's going to be a terminating case where the entire logical flow converges at the same time and exits. And that's basically what this thing says, right? This is statement one, this is statement two, depends on whether the expression is true or false. And then after that, your flow control exit, right? Either from here to here or either from here to here. And it converges at this point, which is, let's say this is line, right? 20, right? So your conversion will be line 21. Okay, that's where this is. This is line 21. Let's say statement two is line 20, and statement one is line 10, right? Okay, so I just made those number up, but you can see, where we are. So this if statements right here, or basically where this expression is, let's say is line 9. Okay, so it's L9 right here. Okay, so you can see where we are. This is the actual code. And this is the logical flow in its visual representation. So in general, an if statement looks something like this, right? So if, right, statement, right? And then you have the parentheses here, and there could be several lines of statements here. Else, right? And then you have another whole bunch of statements here. I notice that there is no semicolon here, right? In fact, yeah, you wouldn't want to close it with a semicolon. And that's one special thing about this if and else, right? This is a statement without a semicolon. So you got to be careful not ever introducing semicolon at the end of the if and else statement. So that's that. And of course, depends on your logic, right? In this portion, you can swap, right? This bunch of statements with this bunch of statements. You can do a swap. Okay. So it depends on what your logic is. But anyway, as you write codes, you'll know, right? And then you'll put in the appropriate expressions in the right place or statements in the right place. Let's look at this. Expression can have a side effect. Yes, that's true. As you know, expression could be, a variable, right? And let's say if this variable is an integer. And let's say if you write something like this, if, right, I plus plus, and no one would do this, right? But I plus plus is a sign effect, meaning when you execute this, your I, right, also gets incremented. And perhaps that's not intended, but if you have something like this, then this I, if you use later on by another part of the program that expects I to be the original value and not the plus value or plus one value, then you have effectively introduced what's called side effects, unintended value that changes the state of your code. So that said, both true and false statement could be any statement. Like I said, they can also be a null statement. So null statement is interesting. Again, you don't really see a lot of this in C++, but it's simply a statement that has just a semicolon, right? In fact, you can type this in your console applications. If you like to introduce a line of code that has no expression and none of that stuff, and other than just a semicolon, this will actually evaluate. But there's nothing to be evaluated, right? Of course. So both statement 1 and 2 must be one and only statement. Yes, multiple statement can be combined into a compound statement. So in fact, if you just have one line of statement, you can simply write this. If, right, let's just say if true, right? Then we know this is always going to be the case. And you can write printf, right? Something like this, semicolon. Now, in this case, right, you don't have to have a semicolon because it is understood, right? You don't have to have this curly braces right here. If you just have one line of code, you don't need to have this curly braces. That's true in pretty much all of the contemporary language that calls for this similar syntax. With the exception of Python doesn't use curly braces, they use tab, right, indentations. But for C, C++, with Java, yeah, there is only one line, right? There's only one line of statement. You don't need to have a curly. But otherwise, like this, right, you have multiple semicolons, several statements here, then you need to enclose it with some curly braces. Okay, so that's pretty much sort of the high-level overview of some major syntactical rules for if and else statements. Yeah, so this slide illustrates what we just talked about. If there's only one statement following any if and else, you don't have to enclose that statement with a curly braces, even though you can, but it's redundant. You can simply, as a best practice, obviously you indent, right? Indent. You don't have to indent either, but it makes it easy for a developer to understand what it is you're trying to do. And this semicolon is part of this entire expression, is not part of the if and else. So just notice that if and else statement itself, regardless whether you have semicolon, regardless whether you have curly braces or not, if and else statement, a simple one, does not have any semicolon. Okay, so in other words, you don't put semicolons here. Okay, you don't do that, right? Period. This slide illustrates compound statements. So we have compound statements, meaning multiple statements. Yeah, you put in the curly braces here. This one is not a compound statement. This one is a simple, right, statement with only one line. So that's why you don't see curly braces here. Okay, so yeah, this is what we illustrated earlier. This is a quick illustration of the swapping of the logic. All you need to do is to put in the complement expressions. Okay, so the complement of not expression. So not expression is actually part of this in this area. So you can actually swap the right, depends on what your expression is. This is a graphical illustration of a null statement, right? So we talked about this. Null statement means this, exactly it, that this one line of code with nothing in it other than just this whole bunch of spaces, right? You can have 10 spaces if you like, but the point is that there's only one semicolon with no expressions whatsoever. In fact, a lot of times you would have an expression with corresponding complex statements, right? Involved in a decision making. So sure, once this is done, you can care less. You don't really need this, right? This entire thing, because there's really nothing to carry out from operational standpoint. So if that's the case, you can completely just ignore it, right? This entire thing could be done, right? So simply put, having this else with the semicolon with the null statement is equivalent, right? The same, right? As writing what you have on the left side here, on the right side here. So a lot of times programmers just eliminate the use of else because this is simply just redundant, right? Instead, you'll be writing something like this, okay? So I just want to introduce this concept of null statement, the fact that just having a semicolon in a line of code compiles. So this slide, we're playing on expressions here, right? As you can see here, if the expression this leads to this null statement, you can just turn it around, right? The complement of expression is not expression, right? Or not, they're turning it, right? So that way you can bring the entire thing up there, and then that gives you this. But this, of course, is redundant. Like we said, null statement is never evaluated. In that case, you can simply just turn this entire thing, this entire use case, right, into this. This is how you simplify your code, right? Simplify code. And simplified code is good, right? Because, right, it eliminates the need of having to write complex logics where no one really understands. So this is an example of two-way selection. You can follow this along. In fact, this one is quite long, but once you get a hang of what those conditional statements are and the values evaluated, you'll get better at this. So let's move on to nested if statement. So the logic is very similar to just having that single if and else statement. So now that the difference is you actually have a nested if statement, if and else statements right here, right? In fact, inside this if, you can have another if else, right? So this is 3 levels deep. You can have 4 levels deep. So my recommendation is never write something too deep because, again, human mind, right? It's only their attention span is only so good, right? For the first 15 minutes, not minutes, 15 seconds, maybe 30 seconds. And after that, right, it'd be hard to keep track of these mentally. So you don't want to do mental arithmetics all the time. So keep this as shallow as possible. But let's look at this expression. So this expression number 1 is actually this, right? The second one is what's in yellow right here. You just be a little careful if this entire thing, right, has multiple statements included in this fact. If this entire thing is as simple as this, right, you don't actually have to have a curly braces here, okay? But it's always a good practice to have curly braces. That way, it's clear to developer from a code maintenance standpoint in the future, like allowing developer to understand exactly what you're trying to get to. You can follow along the logic flow. Again, this entire statement can also have nested on this side as well. You can have nested again on this side, and it becomes deeper and deeper. So this is a hopefully good illustration of nested if statement. This is the code illustrations for, in fact, nested if statements, right? Let's look at the actual implementations here. So if you move down a notch here, line 17 through 23 here, you see the if and else nested statements here. Recommendation is if you can't put on a stop, a breakpoint and try to debug into it, you can see the actual value coming out of it. There's a separate how to debug lessons where we talked about various different ways to debug your code. If in doubt, like this, you can just print out the value of A and B at a given time because you really can't stop the runtime, right? A lot of times these things just print. So the way to really stop the runtime and see what those values are at runtime is to what we call debug. So you can use debugger to go in there and play around, with the runtime system to gain a better understanding of what things are, right? So let's go through this specific use case here. And this is basically saying else is always paired with the most recent unpaired if, right? So let's take a look at what this really means. So what you see here is you have a nested if and else statements here, right? So this if, right? And then this if again, right? And then there's an else, right? So when this happens, this else, right? The second else is paired, right, with most recent unpaired, right? The most recent one is actually this, right? If this if is already paired, then no, we're talking about unpaired, right? And this one is also unpaired, right? So there are 2 unpaired if here. So which one should this else be with? You should go with the most recent unpaired, even though this else here is not properly indented, right? So from the looks of it, it looks like this else is here, right? But that's not true, okay? So always remember formatting your code is of utmost importance. This makes your code a lot more maintainable than a code that looks like this, right? Where things are not properly indented. So this is this illustration actually draws out, illustrates the situations you have on a website. Let's look at this other situations here where you don't really have the same scenario as the previous one because now that you've had, these curlies, right, that encapsulates the very first if, right? So in this case, pairing this else to the closest unpaired if doesn't really work. And if you think about this, is in this closest unpaired if is already encapsulated in this, right? So it belongs in this gray box just right here. So this else then in this case goes into this if. So this is another way of safeguarding your code, making sure that you don't have dangling or stray code or logics, right? That goes to places where they're not supposed to go to by using this curly, right? Begin curly and close curly here. To contain, right, all of your logic in one place. If in doubt, you want to use your curly braces as much as you need to illustrate your point. That is what's called a good coding practice. This calls for simplification of your logic. Basically, we're talking about the expression specifically here. So when you have a not equals 0, another way of expressing is this. We frequently see this as in professional codes too, in commercial code, where people don't really write out the entire thing. You can pretty much says if A, right, then statement. People do this a lot also in Java as well. So just to remember that the shorthand for this, which one is better? It depends on how complicated your logic is. Sometimes you can have a comparative statements in there, and it involves just single variables on each side, right? It becomes very hard to read, but sometimes just by writing this out, the original statement, this is not bad, right? Not bad, right? And this is not good either, right? So sometimes you kind of see what which one is easier to read. Lots of times, especially beginner developers, they find this really hard to understand, right? But if you really think about this, right, what is this A? A is a single, right, value expression, right? A single value expression because this expression evaluates to something, right? So A, right? If you put it in the context, this A has to be an integer, right? Or Boolean, right? So what is A? Well, A is going to give you a value. So if this value is not 0, then this is going to be true, right? So if A has value in it, not other than 0, then this statement is to be evaluated. If A is 0, then this statement is not going to be evaluated, right? Because 0 evaluates false, right? So you really have to kind of think about this. Whenever you see a single value expression or some literals here or variable, in this case, actually, this is not even a variable. So when you see a variable here, the next thing you should do is think about what is the value of this variable, right? And then that way you can understand, how the simplification actually works and the meaning of the statement. So let's look at this conditional expression. This is what we call ternary, okay? This is ternary conditional. So there's actually 3 things that we're looking at here. One is the comparison itself, right? A equals B, right? Is A equals B from value standpoint. If true, right, then it evaluates this, right? This is this question mark here. If true, TRUE, then it goes here. If A is not equal to B, then false, right? Then D++, right? We know what C++, D++ means, assuming C and D, right, are both integers. So you can increment the value of C by 1 or D by 1, depends on whether A is equal to B or not, right? So this is a conditional expression. This conditional expression evaluates true or false, right? False, this, true, this, right? And then after that, whatever the next line is, right, is the convergence, which is here, right? So this convergence shows here, and that's where your flow of control or logical flow is according to this particular type of code. And as you can see, the reason why this is the case is because equals this comparative operator carries a higher precedence, right, than the question marks. as well as the colon itself. So this is the reason why this is evaluated first, and the evaluation goes from left to right, right, in this fashion. So this is how ternary conditional expression works in practice. The remaining portion of the current slide calls for an example tax rate problem. As you know, in the States, depending on the tax bracket, you pay a little more tax rate. So there is actually a formula or two involved in how much a person makes per year in a tax bracket and a tax rate and things like that, right, to compute. So this is a table that kind of illustrates some of the key elements that we have in the formula. And then the very next slide shows the design, right? So the architectural design, right, for your software program that computes a person's tax, right, based on these various things. So I won't get into this. This is a very good exercise or read for you. There is plenty of illustrations in these screenshots that shows how this text computations work from a logical standpoint, right, page by page. So you can kind of go through these, or if you like, type them out in your IDE as you go, but follow this entire design. This is a conditional flow chart, a decision chart that shows you based on the text bracket, and then the decision calls for if, right, if income is less than the start limit, if true, right, if false, right. So there's a decision here. So you can use it if and else. So true goes here, false goes here, and then right. So true, false, or the other way around. So it depends on what this is. So you can actually just read into it, but at some point everything converges to a return statement at the end. Right. This is how everything kind of ends. Your entire flow of control goes back to the operating system, completely absorbed by the system to end your program.